Alright guys, how you doing? This is beginning of chapter 2, the classification of matter. Talk about elements, compounds, and mixtures, and then some about chemical reactions, and then types of mixtures as well. So, matter is all around us. Everything that has some composition is matter. We have elements, about 118 right now, and everything is made of elements. And then you can make 20 plus million compounds from these different elements that are chemically bonded together. And then from that, you have infinite number of mixtures. So you get like a simple solution of soda is a mixture. It has all these different compounds in it. So easy way to think about elements is think of like a nut and a bolt. These are separate things. They're alike with each other. So a nut and a nut are very similar, are the same, and then a bolt and a bolt are the same. We can make a compound by attaching the nut to a bolt. Now you have a compound. They're bonded together with different elements. Where a mixture is taking a bunch of different elements and a bunch of different compounds, and they are similar. They have different bolts, screws, nuts, different sizes, and they're all mixed together. So you have some elements, some compounds, and different sizes of different elements and different sizes of different compounds. So elements, they're the simplest form of matter. Everything is the building block of chemistry is our elements. So everything in the universe is made of elements. Hydrogen makes up 99% of the universe based on the stars and gases around. Elements are made of atoms, which are similar, and then atoms of different elements are different. So if you have an element of hydrogen, the atoms of hydrogen are very similar. Where if you have a different element, helium and sodium, they are different elements, they are different atoms. We have final number will be 118 elements. And that's what is on the periodic table currently. So the periodic table is mostly metals. Those are the green elements. So everything from the mid-right over to the left are metals except hydrogen. Hydrogen is a gas. It's non-metal, but acts violently and reacts very well, so it's considered a part of that family. The gases or non-metals are to the right, and then you have these blue staircase, and that's called metalloids, which they have similar properties of both metals and non-metals. They have some metallic properties and then some non-metallic properties. Diatomic elements, so these are ones that you want to memorize. Diatomic means two, so they are elements that will combine with each other to form a molecule. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and then sometimes iodine and acetylene are going to be diatomic. Generally they are, and which means that when they form a molecule, they form with each other. So when they are in its normal state, they're a molecule of H2. You don't find hydrogen atoms floating around. You find hydrogen molecules floating around, or oxygen molecules. So when you breathe in oxygen, it's actually an O2 molecule that we're taking in, not an oxygen atom. Compounds are taking basic elements and then they form together. So they're different elements that make a substance. So two or more of the substances chemically combine, making a bond that make a new chemical and different properties. Compounds have a fixed composition, so no matter what, they're always going to have the same ratio. So like water is always H2O, meaning that there's always going to be two hydrogen atoms for every one oxygen to bond. H2O is always going to be H2O. So you have reactants, which are your starting materials. It could be elements, it could be compounds, it doesn't matter. It's just your starting materials in a reaction. And then when they make a product, that's your right side of the equation, it produces something different. So reactants are the left side, that are your starting material, and products are your right side, which is your production of something different. So for this example, if you take iron and sulfur and you heat it, you get iron sulfide. So you go from two elements to a compound. Where aluminum and bromine, same thing. So notice bromine is diatomic, so that Br2 means that it's bonded to each other, so it's diatomic because it's one of the 7 elements that are diatomic. So reactants are going to form a new compound into aluminum bromide, which basically is a different physical property. Aluminum is shiny silver, bromine is reddish liquid, and when they mix, they make a different color. So how do you know a chemical reaction occurs? There are 5 indications. 1, you see a color change. 2, there's a temp change. So when we did our reactions with magnesium and acid, you felt that an increase in temperature. So it's exothermic. It could be also a decrease in temperature. 3, gas. So again, we saw gas get created when you react with those 2. Appearance of a precipitate. So a precipitate is a solid that forms when 2 liquids combine. So you can see in this picture the yellow solid forming when you added 2 liquids. That's a precipitate. And then light. So every firework that gets generated is a chemical reaction because you're producing light. Law of conservation of mass. So a chemical reaction is like a balance beam. You cannot create nor destroy chemical and physical changes. So whatever you start with, you have to finish at the same amount. So for example, if I were to burn a log and I produce ash and smoke, it has to be the same amount of mass that I started with. Obviously, we're not going to collect smoke, so you actually have less when you start with because there's smoke going in. All right, mixture. So a mixture is defined as a combination of 2 or more substances in which they retain its own chemical physical properties. So there's no reaction going on. So you're basically mixing things together and nothing's changing to its physical properties of each chemical. And generally, mixtures have no fixed composition. The amount of one or more components are usually a wide range. So it doesn't have to be a particular mixture or composition. So for example, if you were to make a salad, one salad one day, it's going to be a different salad the other day. So you might have exactly the same amount of tomatoes or exactly the same amount of lettuce. But they're mixtures, both called salad, but they're different compositions. 2 major classifications of mixtures. You have homogeneous and heterogeneous. Homogeneous is the same throughout, where heterogeneous, they are different throughout. So examples of homogeneous are air, milk, salt water, soda, iced tea, lemonade. Heterogeneous are suspensions or completely mixed up. So like salad dressing, you have to shake it, and it's a heterogeneous mixture because it's not the same throughout. Dirt, you go one spot of dirt, you might get a different composition, another place of dirt. Orange juice is suspension, especially if it's pulp. You have to shake it up. And all the other ones are basically not even throughout, would be a heterogeneous mixture. So it's different types of homogeneous mixtures. You have solutions, which are basically just a mix, something solid dissolved in water. They're very, very small. The sizes are very, very small. So like salt water, you can't see the salt. You can taste it, but you can't see it. So it's a solution. It can't be filtered out. And if you shine light at it, it does not scatter. I'll show you an example of that. You can also have solid solutions called alloys. Alloys are mixtures of metals. So when you have a piece of steel, it's a mixture the same throughout of iron and carbon and other different metals like zinc and whatnot. And 14 karat gold is a mixture of gold and copper. Bronze is a mixture of copper and tin. So most metals you buy at the store are usually mixtures. even our jewelry are mixtures of different metals. So here's some examples. So ocean water, the solvent is what's being dissolving, or what's doing the dissolving. And in ocean water, you have salt, carbon dioxide, oxygen. Those are the solutes that's dissolved in the solvent. Air, generally the majority of our air is nitrogen, and then some of the solute, water vapor, carbon dioxide, oxygen. The smaller amount stuff is the solute. Soda, you have sugar, CO2, flavoring. Those are all solutes that are dissolved in water. And 14 karat gold. Good gold is the majority of it, 58%, whereas 42% is copper. So the higher amount one, the solvent, is going to be gold, and the smaller amount one is going to be copper. All right, colloid. So the other type of homogeneous mixture besides a solution is a colloid. So this, again, cannot be filtered and it doesn't need to be mixed, but it does scatter light. It's called the Tyndall effect. So some examples are fog, foam, smoke, jello, egg white. Those are all colloids because they're the same throughout, but they can scatter light. So the particles are a little bit bigger than a solution. So this is what the Tyndall effect looks like. Basically, you shine a light, and it could be a flashlight or a laser, and if it makes some visible indication that you can see, it's a colloid, and where it's not visible, it's a solution. So you can see the difference between a colloid and a solution. They're both homogeneous mixtures, but the solution have particles a lot smaller, where the colloid, the particles are a lot bigger, therefore they can scatter the light. All right, heterogeneous mixtures. This is one of the easiest ones. They can be seen through the naked eye. They can often see through the naked eye. They can be separated through a centrifuge. They can be separated through a filter. They do scatter light, or even stop a beam because it's so dense, like ketchup. So examples of suspensions: paint, they have to be mixed up, salad dressing, orange juice, ketchup. All those have to say shaken before using because they are suspensions. So you want to try and get as much as the components to be the same throughout by shaking it. Blood can be centrifuged. So you have plasma in the blood, white blood cells, and you have red blood cells. So when you have a high enough centrifuge, these can be separated. Therefore, it is a heterogeneous mixture. All right, quick review. So we have matter. We have the elements that are basically made of all the matter in the world, the universe, that make up 20 plus million compounds. And then you have mixtures. So mixtures, you have heterogeneous and homogeneous mixtures, where in the homogeneous, they don't need to be shaken. You have solutions that do not scatter light, and you have colloids that do scatter light. And then in heterogeneous mixtures, you have suspensions that need to be shaken, which generally are going to scatter light or stop light permanently because they're so dense.